Beautiful question, beautiful question. And what are the maximum and minimum possible express values for this? First of all, I'm going to think about each term. Right? So what can this go to? Maximum and minimum. So modulus of x plus y by mod x plus mod y. Nice, interesting. We know that mod x plus mod y, we're adding the two magnitudes. Modulus of x plus y, we're adding the two numbers and then taking the magnitude. And straight away we can sense that mod x plus mod y greater than or equal to modulus of x plus y. Nice. Because we're adding the two magnitudes, then we're adding the two numbers. We're adding two numbers. If one number is positive, other is negative, the magnitude will shrink. Mod 5 plus mod 3 is mod of 5 plus 3. Mod 5 plus mod of minus 3 will be greater than modulus of 5 minus 3. X and y have opposite signs, then their magnitudes will kind of cancel each other, partly at least. And then modulus of x plus y will shrink, whereas mod x plus mod y is sum of the two magnitudes. When will it be equal? It will be equal when they have the same sign. So, lovely idea. Mod 3 plus mod 5 is equal to modulus of 3 plus 5. Mod minus 3 plus mod minus 5 is equal to modulus of minus 3 minus 5. Mod 3 plus mod of minus 5 is greater than modulus of 3 minus 5. They have opposite signs, it crashes out. It becomes smaller, these two will be greater. So mod of x plus y by mod x plus mod y will be 1. Maximum equal to 1. What is the minimum? It will be 0. Because modulus of x plus y can go to 0 when x is equal to minus y. It can go to 0. Brilliant. When modulus of x plus y can go to 0. Modulus of 3 plus minus 3 is 0. So each of these expressions goes from 0 to 1. This goes from 0 to 1. This goes from 0 to 1. This goes from 0 to 1. Nice, very interesting. So the overall total should go from 0 to 3. Maximum is 3, minimum is 0. Now, when will the maximum happen? Suppose I put x is 2, y is 3, z is 4. 2 plus 3 by 2 plus 3, 3 plus 4 by 3 plus 4, 2 plus 4 by 2 plus 4. Brilliant, 3 is possible. Can I get 0, 0, 0? Is that even possible? And that's where it becomes funny. Because if I put x equal to minus y, this will go to 0. You put y equal to minus z, this will go to 0. Y is minus x and minus z. That means x should be equal to z. Here again I cannot say z equal to x. Z equal to minus x. That's not possible. X, y and z. X and y can have opposite sign. Y and z can have opposite sign. Again x and z also cannot have opposite signs. Of the three numbers, all three can be positive, all three can be negative. In which case it will add up to 3. Nice. 2 can be positive, 1 can be negative. 2 negative, 1 positive. If we sum two numbers at least that have the same sign, in which case it cannot go to 0. We cannot have a scenario where this goes to 0, this goes to 0 and this goes to 0. That's not possible. I can make two of them go to 0, in which case the third one will end up being 1. So I can have a mechanism where these two go to 0, in which case this will be 1. These two go to 0, in which case this will be 1. One of the three has to be 1. I cannot have all three numbers, every pair having different sign. I cannot have plus and minus, plus and minus, plus and minus. Not possible. If x and y have opposite signs and y and z have opposite signs, that means x and z should have the same sign. I cannot have x and y having opposite signs, y and z having opposite signs, z and x have opposite signs. That's not possible. So of these three terms, at least one of them is equal to 1. So the minimum is 1, maximum is 3. When will it be 3? I put x equal to 2, y equal to 3, z equal to 4. This expression total would be 3. I put x equal to 2, y equal to minus 2, z equal to 2. This expression will be equal to 1. Minimum is 1, maximum is 3. Below 1 is not possible because one of these three terms has to be 1. Above 3 is not possible because each of them maximum is 1, goes from 1 to 3. Greater than 3 is not possible, less than 1 is not possible. Absolutely delightful question, and absolutely brilliant question. And so thinking about how the modulus idea works. I'm going to stop with this. Model is a beautiful idea. Polynomials, algebraic expressions, functions, very interesting topics. The whole idea of what this entire class is to say some questions are intimidating. So pick and choose your battles. 1. 2. Even the intimidating questions, don't just straight away look at it and say there's a cube here, there's too difficult, there's a modulus here, and then leave it at that. Have a poke. There could be something that just simplifies it to a beautiful, delightful, simpler, still challenging problem that can be done. So lots of questions in competitive exams are of the type where it looks intimidating, but after a couple of steps it becomes challenging but very doable. To back yourself to say, okay, I'll find that one thing that can unlock this into a smaller menacing question, not a giant menacing question. In the exam, you have to have the wit to say, okay, I'll poke around, I'll see, and you should have the pragmatism to say, okay, I've done 1 minute of this. Maybe it's just a long question, in which case I'll leave it, or I don't know how to unlock it, again, in which case I'll leave it. You should have the confidence to poke around, look to simplify, and the common sense to say, if it doesn't get simplified, say, look, I'll leave this question, I'll find my 40 marks from elsewhere. Both are important. Fine.